this is clear. Oh, I'm supposed to do a video? Good. This is all mine. Hello everybody, this is Great Math, number 9. And by the way, JP, he steals all my stuff. You tell him that he ain't doing that again. Okay, it's supposed to be secret of disability. Oh yeah, this one I specifically made. Remember, I did not tell you this. Okay. Oh, now you're probably thinking, what is divisibility? Well, divisibility, what do you think? Divisibility is supposed to be something that is evenly distributed. It's basically division without a remainder.
For example.
8 divided by 4, it's equal to 2. No remainders. It's
And
evenly
5 and 2?
distributed.
5 divided by 2?
5 divided by 2. That is not evenly distributed, which is not
because
divisibility.
It's 2.5, so it's not?
So it's 2.5. Has to be a whole number. No points, no halves, no fractions, nothing. By 1. Any number. Let me write all these out first before I do anything. Number 2. At the end of the number has to end with 0, 2, 4, 6, and 8. For number 3, you have to add the sum. You have to add the sum of the number. And if all that equals to 3, like if it's divisible by 3, then it's right.
If it gives you a number that is divisible by 3, you mean?
Yes.
Okay.
Number 4. If the last number, so last 2 numbers, 2 digits, if it's divisible. If it's divisible. If it's not divisible, if the last 2 numbers isn't divisible by 4, the entire number isn't. 5 has to end with 0 and 5. Number 6 has to be divisible by 2 and 3. Number 7, we ain't got one. Sorry. Number 8 has to be divisible by 2 and 4. Number 9, you have to add the sum of the number. And if it is, then yeah.
If it is divisible by...
If it is, then yeah, it is.
If it is divisible by...
If it is divisible by 9, then yes, it is.
Okay.
If this ends with 0, it is divisible by 100. It is divisible by 10. Now let's go to the proof. You guys are thinking, who is this guy thinking? There probably is no way. Well, I'll prove it to your face. Boom. Let's try 618. Is it divisible by 1? Yes. Is it divisible by 2? It's an 8, so yes. Is it divisible by 3? 6 plus 1. What is that, people? 7. 7 plus 8. 15. So yes. Divisible by 4. Well, 18 is not, so no. 5. Well, it doesn't end with 0, 5. Number 6. Well, yes, it is, because it's divisible by 2 and 3. Number 7. We don't know for sure. So we'll hold on to that. Number 8. No, number 8, because no, it's not by 2 and 4, so no. It's by 9. Add it, that's 15. No, by 10, doesn't end with 0, so No. Now, 7, we'll actually try that. That is, you do by 8, it's 56, it's 4, 8, that's by 6, that's by 6, remainder 6. So no, it is not. No, it is not. Now let me prove you to your party. It's equal to 600 times 10 plus 8, which is equal to 6 times 100 plus 1 times 110 plus 8, which is equal to 6 times parentheses 9 plus 1 plus 1 9 minus 1 plus 8.
Minus 1, you sure?
Whoops. Which is equal to 6 times 99 plus 6 times 9 plus 6 times 1 plus 1 times 1 plus 8. Which?
No, 6 plus 1 times 1, is that right? Oh, I'm wrong. Look.
Huh?
Plus 6 times 1 plus the second one. What is it? 6 times 1, yeah, plus 1 times 1 maybe?
Yeah.
Okay, that's one, okay.
And since 99, so all of these, if all of this equals to, is divisible by 9, this is divisible by 9, this is divisible by 9, then it is divisible by 9. Let's see. 99, that is divisible by 9. That means it's divisible by 3. 9, it is divisible by 9, which also means it is divisible by 3. 6 times 1, that's 6. That's 1. 6 plus 1 is 7. 7 plus 8 is 15. That's 15, which is divisible by 3. Oh, in your face. And you probably know, plus you don't have to do this. We already know the answer is going to be 3, which is nothing, 0. 18 is 9. 309. So yes, it will be. We already know that. You guys can do it back in where you are. So it is divisible by 3. Since it is divisible by 2 and 3, yes, it will be by 6. Is that enough info for you? Oh no, people are coming. Okay, this is me. Make sure remember, JP, he does not know anything. He took it from me. I am the hooded guy. And see you next time if I can. Well guys, hold the phone. I did a mistake in Great Math number 9. I did a mistake. The way that you do 8, as you can see here, how to see if a number is divisible by 8 is not if it's divisible by 2 and 4. That doesn't work all the time. For example, I saw 1916 is not divisible by 8. Why is that? Okay, let's do the way. So by 4. So by 4, how we're doing it by 4. So the bottom part, yeah, it's divisible by 4. So yeah, that would be done. And from 2.
The 2 last digits, you mean?
Yeah, the 2 last digits, that would be 4. Number 2, well, it's an even number, so yeah, okay. Now let's try it from whole. Okay, so 8 divided by 1, 9, 16. 8 divided by 19, that would be 2, that would be 16. There's 3, 1. You can't do 4 because it's not 32, so you have to do 3. 24 minus that's 2, that would be 11. 7, bring down to 6. And 72. 9 and impossible. It's divisible by 2, and it's divisible by 4, but how? Well, luckily, there is actually still a way. There is actually still a way that you can figure out. Okay? So by looking all through where I could, I found that you probably are not thinking that 1,000, it is divisible by 8. 8 goes to 125. So basically all you're looking is the last 3 numbers. So from what we're looking from here, now all we need to know is, since 1,000, okay, anything under it is basically the real problem that we're looking for. Like all the digits that are lower than 1,000, that's the digits that we're looking out for. Okay? Still with me? Okay?
Can you give an example?
For example, yeah, okay. Okay, let's do... Okay, I'm just going to make up a number. I'm not sure if it is. 2, 4, 6, okay. It's divisible. Well, let's see. So remember the last 3 digits. 246 divided by 8. That'd be 3. 24 minus 0 minus 6. No, it is not.
So another number.
Let's see.
Well, what was the reminder of the... Okay, try it.
Let's see. 8, 2, 4, 8. 3, 24 minus that'd be 0. The 8, that'd be 1. 8 minus that's 0. It's 8 remainder 0, so basically, yes, it is evenly distributed.
So, it's no reminder. So,
yes,
what is the number? So, can you prove it? 1248 equal what?
1248.
Yeah, equal.
It's equal to
So
it's equal
240. No, it's equal to no.
Yeah.
No, 1,000 plus
1,000 is 200 plus.
No, plus 248. You look only at the 3 last digit. You said.
Yeah. No, but just let me.
Okay, go ahead. I'm sorry. Go ahead.
Just let me explain.
Okay.
Okay, 1,000. We already know that's divisible by 8, so that's already checked. 200. Well, that'd be 25 times 8, so yeah, that'd also work. And 48. Well, that's just 6, so 6. That's evenly distributed because it also can be like 8 times 6 would equal to 48. So yeah.
Okay, so how do you find there that the 3 last digits are divisible? Okay.
You can know, or in other words, you can do it this way, like you were thinking. 248. If that one.
Because you did that.
Yeah, you made it into a longer sum. So you took this out. So you took out the 1,000 out of the 248, which we already checked that is divisible by 8. So yeah. Now you're probably wondering, it's just kind of too hard. This is too hard. I just want someone to walk in and tell me, there's an easier way, and da-da-da. Well, you'd be waiting for a pretty long time for that. Pretty long. Because so far, there is no. Sorry. So basically, and now you're probably thinking it's the same thing by 3. The same thing by 6, because it's 2 other numbers. So we already know that 8 is to find if 8 is divisible by a number, it has to be divisible by 2 and 4. We already know that's false now. Now you're probably thinking it's the same thing by 6. Well, no, it's not. You can even check all through the list. It is divisible by 2 and... So here, let me give you an example. 312. Well, that'd be 4. 4 plus... That'd be 6. So yeah, it is. So yeah, it's divisible by 2. It's an even number. So yeah, it is divisible by 3. Now, those are the only requirements. Now let's do it by 6. Okay, you can't do that. You do it by 4. No, actually, no, you should do it by 5. Sorry. 30 minus that'd be 1. Bring out to 12. That's 2. It's evenly done. You guys can do any other examples. I tried to look for a lot of examples. It didn't work. So remember, I'm Jean-Pierre Malouge, and this is Great Math Continued of number 9. See you next time.